So what we have here, an assembly line makes engines. 2% of them are fatally flawed, so they go boom, they explode. And 50 engines are produced. And so the question is, what is the probability that at least, and that means something of course, 48 engines are not flawed? I definitely do not have enough space for that. Okay, so I'm going to kind of do this in two ways. I'm going to define success differently, basically. So we're going to have our success and P, Q, X, success and P, Q, X. Okay. So what I could say is, I could say that a success is, let's use the traditional definition of success, that the engine is good. So how many trials do we have? We have 50 engines are produced. We have 50 trials. The probability of one being good is 98%. The probability of being bad is 2%, or 0.02. And we want at least 48 to be not flawed, so at least 48% to be, at least 48 to be good. So we're going to have three cases. It's going to be 48, 49, or 50. And what's that going to do? So we're going to have cases. So we're going to say, okay, what is the, probably let's get a tighter pen for this one. I'll use my new blue. So we want the probability that x equals 48, and that's going to be 50 choose 48 times 0.98 to the 48 times 0.02 squared. We're going to have the probability that x equals 49, which is going to be 50 choose 49, 0.98 to the 49, 0.02 to the 1. We're going to have the probability that x equals 50, and that's going to be 50 choose 50, which is just 1, by the way, 0.98 to the 50, and 0.02 to the 0, which is also 1. So let's go calculate all these things. So it's going to be 50 choose 48 times 0.98 to the power of 48 times 0.02 to the power of 2. And that's going to be 18.6%. And then we're going to have 50 choose 49 times 0.98 to the power of 49 times 0.02, which is going to be 37.2%. And then we're going to have this one, 50 choose 50 is 1, that's 1, so it's really just 0.98 to the 50, which is going to be 36.4%. And so the probability of having at least 48 good engines is going to be adding those guys together, which is going to give us a grand total of 18.6 plus 37.2 plus 36.4, which is 92.2%. So there's a 92.2% probability that at least 48 of the engines are good. Okay. Now, I promised to do the other thing. I think I may cut it short. I may not do the whole calculation, because that took 4 minutes already. So, obviously, the opposite of what we could say is we could say that success is fatally flawed. So we still have 50 trials. Now the probability of it being fatally flawed is 0.02. The probability of it not being fatally flawed, of it being good, is 9.8. Now the question is, what is x going to be? So we want at least 48 not flawed, right? So at least, so I think we have 50, 49, 48. These are the good ones. And the corresponding flawed ones would be, if you have 50 good ones, you have 0 flawed. 49, 1. 48, 2. 47, 3. But what we want is we want 48 or more that are good, which means we want 2 or less that are bad. So this is like saying, so saying at least 48 good is like saying at most 2 bad. And the cases are going to be 0, 1, and 2. So notice, changing the definition of success doesn't actually change the number of cases. We have 3 cases. We still have 3 cases. It's just they're going to be different. And if you calculate those 3 cases, you would also find that the probability was 92.2%. Okay, that's not too different, but let's do the hard one now. What's the probability that at least 2 engines are flawed? Which sounds kind of similar. So, but it's not. So what it's going to be is, let's say that, oops, that's not the one I wanted. All right, we'll do another page anyway. So you want at least 2 engines flawed. So the probability that at least 2 are flawed. So success N, P, Q, X. And that's going to give us, so we're going to say success is flawed. We have our 50 trials. The probability of it being flawed is 0.02. The probability of it not being flawed is 0.98. And if we want to have at least 2 flawed, so we want to have at least 2 that are flawed, the probability of that one, it's going to be 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 49, 50. That's a lot of cases. That's going to take us a really long time. I don't particularly want to do that. So what we're going to do is we are going to change our definition of success. And we're going to say that success is going to be, so success N, P, Q, X. And so success is going to be not flawed. And we have our 50 trials. And the probability of not being flawed is 98. And the probability of it not being not flawed is 0.02. And our X is going to be, so let's go through that again. So we want, it's not really going to change anything actually. Because if you remember, it doesn't change the definition of success, doesn't actually change the number of cases. What we're going to have is 50 flawed is like, if we want to have, so what it's asking for, at least 2 flawed, that's like saying that, right? So if we look at over here, at least 2 flawed is like saying at most 48 good. So this is like saying at most 48 good, which means we have 0, 1, 2, 3, 4, 5, 6, all the way up to 48. That's a lot of cases as well. So that's not going to work either. What we're going to do is we're going to do this indirectly. So those are the X's. We can actually say, what are the non-X's? So what kind of, how many successes do we not want? And the number of successes that we don't want is 0 or 1. Or if we look at it this way, the number of good engines that we don't want is going to be 49 or 50, because if we have 50 good engines, then we don't have at least 2 of them that are flawed. And then we could now figure that out. So we could say, okay, so we want For this one over here, the probability that x equals 49, and we already did that, didn't we? We did, so we're going to steal that. So the probability that x equals 49 was 37.2. The probability that x equals 50 was 36.4%. And we'd have a similar thing on that side as well. And so if we add them up, we get 37.2 plus 36.4. So there's a 73.6% chance of getting essentially a bad case of what we don't want, of not having at least 2 flawed engines. And so doing our good equals 1 minus the bad, it's going to be 100% minus 73.6%, which is 26.4%. And that would be our answer. So the probability of having at least 2 engines that are flawed is 26.4%.